let's try finishing that. I think I pressed the wrong button. Anyway, a positive quadratic means that a is greater than 0. So an example would be y equals 2x squared minus 3x plus 6. Once again, this is where a is greater than 0. That just means, once again, it's positive. A negative quadratic would be if I just changed my leading coefficient to be a negative 2x squared. Now, we don't talk about quadratic growth and quadratic decay because technically all quadratics grow and then decay. So instead we talk about one being positive, meaning it opens up, or negative, meaning it opens down. So the graph of a quadratic is a U-shaped parabola. And our key words with our graph are vertex, and remember we have a max or a min with these, and zeros or roots. Those are just our x-intercepts. An example of a positive quadratic, I'll sketch my axes again. Positive quadratic means it opens up because positive people bring you up. A negative quadratic is one that opens down because negative people are downers. Remember that? Yeah. Okay, what I want you to really pay attention to is the stuff with the table, okay? When we look at a table and we look for a first difference, it's not going to be constant. But when we look at the second difference, it is a constant. Okay, and we haven't done this before, so really pay attention. Look at my table. To go from 4 to 1, I subtract 3. To go from 1 to 0, I subtract 1. To go from 0 to 1, I add 1. To go from 1 to 4, I add 3. Those don't really look anything alike, right? But now if I look at the second difference, so I pretty much am going to look at this row right here and do the same thing with my arrows. How do I go from negative 3 to negative 1? Add 2. How do I go from negative 1 to positive 1? Add 2. How do I go from 1 to 3? Add 2. Do you see how those are now the same? So that means it's a quadratic because my second difference, meaning my equation is to the second power, is constant. Okay, let's look at what happens when we have a negative quadratic. How do I go from negative 4 to negative 1? Add 3. How do I go from negative 1 to 0? Add 1. How do I go from 0 to negative 1? Subtract 1. How do I go from negative 1 to negative 4? Minus 3. Doesn't look the same. Let's look at our second difference. How do I go from 3 to 1? Subtract 2. How about 1 to negative 1? Subtract 2. Negative 1 to negative 3, subtract 2. Once again, my second difference is the same. Notice that the difference between a positive and a negative quadratic is that in a positive, my second difference is positive, and in a negative quadratic, my second difference is negative. Go figure. Okay, last, how do I know it's a quadratic when I'm looking at a word problem? Usually it has things like that are flying through the air. We have things like a maximum, a minimum, or it says something like hit the ground. So I just gave you an example over here. When it has a minimum value, when does a ball reach its maximum height? Those keywords tell me I'm dealing with a quadratic. And the last type we've looked at are exponential functions. We only have one equation for an exponential function, and it's y equals a times b to the x. And remember, a is our initial value, and b is our multiplier. So an example of exponential growth would be y equals 2 times 1.08 to the x. Exponential decay would be like y equals 2 times 0.8 to the x. To tell it's exponential from a graph, it means that it either decreases or increases quickly. And my A is usually my y-intercept. Now, if I've added or subtracted something at the end of my equation, that's going to change, so be careful. And then we had that thing called the asymptote, remember, where my graph is approaching that y value. Example on a graph of exponential growth. It's going up from left to right. Make sure it doesn't look like a parabola. It decreases or increases pretty quickly. In a table, we've talked about this. Y changes by multiplying or dividing a constant amount. So let's look at this example of exponential growth. How do I go from 1 to 4? Multiply by 4. How do I go from 4 to 16? Multiply by 4. How do I go from 16 to 64? Multiply by 4. Notice I didn't even try doing this with linear, because if I look, to go from 1 to 4, I would add 3, and then I would be adding 12. That would not work. So I'm multiplying. But in this decay, I'm dividing by 3. Or that's the same thing as multiplying by 1/3. Multiplying by 1/3. And in a word problem, we're going to look for keywords like appreciate, depreciate, increasing, or decreasing. I'm going to abbreviate. By a percentage, okay? By a percentage. And then last, words like double and triple. And that's what we have over here. I've invested $1,000 and it increases by 6%. Or I have a population that's declining by 11%. So when I have those percentages, I need to have a big flashing light going off in my head thinking it's probably exponential. All right. See you tomorrow.